Hi guys, my name is Steven. I'd like to welcome you back to my calibration channel. I'd also like to welcome back Maddie and Carl, my two bootstrapping experts. Bootstrapping can help us with our risk mitigation headaches, but it's only magical. It's not magic. We already know that any use of statistical inference automatically introduces risk, but we also know that there were risks present in our environment already. More fundamentally, we can't begin to mitigate these risks until we can see them. So what we're always looking for is more power to see, not magic to make things just disappear. Bootstrapping is an algorithmic method that rode in with modern computers. Before the advent of these computers, a tool as powerful as the Bootstrap was just inconceivable. That's because computation was just too expensive, both in time and money. Brad Efron himself has dated the transition to the modern era of Bootstrap as going back to about 1990. Now, the best way to explain how bootstrapping can help us with risk is to use a specific example and then compare it with a classical approach to the same problem. But I know that as you follow along, you're going to see plenty of places where you might want to try this out because it's so simple. Okay, we're in the playing card business. We make and sell cards for a living. It's vital to our business that we guarantee and control the variability of the weight of our cards. But obviously, we can never get our hands around the entire population of all cards that were ever made. If we could, we wouldn't need to learn and adhere to the rules of statistical inference. Let's say that we take a sample of 30 cards from our production run. We need to see if taking the mean of this sample will satisfy our need to both know and control the variability of the cards we're producing. But the real question is this: does this metric provide adequate protection from the risks that are built right into our process from the ground up? Is this metric going to be good enough for us? Can we safely toss it onto our dashboard and call it a KPI? Well, the classical approach has some strengths. First of all, it's been used for centuries and it's been validated by millions of people. Second of all, it's very easy to do. Third of all, we happen to know that all our playing card competition happen to use the same inference approach to validate their processes, at least for now. Now, there's some weaknesses here. When we calculate the classic mean of this sample, we can only produce a single output per sample, and there's only one path to produce it, so it's useless to do it more than one time. That's because our output has no shape or dimension. It's just one point hanging in space. Also, there's no easy way to look back from this sample back to the population from which it was drawn in case we want to get a glimpse of the distribution. Also, only in retrospect can we see that this inference process that we've depended on for hundreds of years contains some hidden assumptions. These have been around for centuries, and they're both sacred and invisible. But we're about to take an eye-opening look at these assumptions. Now, in contrast to the classical approach, how would we apply the bootstrap here? How could it help us? As we go along, we're going to expose some of the assumptions that I'm talking about. We're also going to see that it's remarkably and even embarrassingly easy to apply the bootstrap to this sample. We start the bootstrap process right after we've drawn this sample. We then gather 30 new samples from the original sample space, but this time we do it randomly and with replacement. So far, the only difference between our new sample and the original sample is that we're almost positive the original sample was drawn without replacement. But this difference means that some cards in the sample space might get missed in this first bootstrap sample, and some other cards might be counted more than one time, because we're still only selecting our own total of 30 sample cards from the original sample. Having broken that rule, we're going to break another one. We're going to redo this 499 more times using the original sample. We could also do it 4,900 more times. The ease with which we can select any number of iterations that happens to suit our need is one of the reasons why this method is sometimes called resampling, because that's what it is. But what we've done here so quickly and so easily is to transform this sample drawn from some population into its own population. And not only that, this population is finite because we happen to know the weight of every card in this sample. And it only took us 350 years to figure this out. What's more, we could all do this 500 times in Excel in less than 5 minutes. Go see for yourself. Go to YouTube and search on Excel and Bootstrap. You'll see, as I did, that the whole thing turns on one equation written in one cell and then a whole bunch of cutting and pasting. One immediate advantage of Bootstrap that you're going to see right away is that immediately and at no cost whatsoever, instead of producing one single dimensionless point in space, we can produce a histogram that shows the variation and dispersion of our 500 Bootstrap means. Now you might stop me right here with a counter argument. You might say, well look, if you wanted dispersion, we could have calculated the sample standard deviation of this sample and done it faster than you did. Well, if you take that position, it seems to me you're not thinking this as far through as Brad Efron did. That's because the Bootstrap has a very powerful attribute. It's non-parametric. That helps us in two ways in this instance. The first is that when we apply the Bootstrap to this sample, we don't care what the distribution is of the sample. We don't care what the distribution is of the population. Now, if you advance the argument that we could have calculated the sample standard deviation right from the beginning, you're basing your argument on the assumption that the sample and the population are normally distributed. That's one of the problems of statistical inference. Sometimes we don't know that. Sometimes we do know that. Bootstrapping helps us because the classic standard deviation still only produces one point in space to represent this sample. If we bootstrap this, we could produce 500 standard deviations from this sample in 5 minutes. What's more, the bootstrap versions would show us the variation and dispersion of the dispersion. That's pretty nifty. Now let me tie this back to risk mitigation. The Bootstrap shows us clearly, rapidly, and graphically that up until now, we had only been able to perceive a tiny piece of the value that was living right in front of us in every sample that we've ever drawn. We just completely missed the presence or meaning of all this value. Now that's a risk that we all survived quite handily. But as a playing card company, are we willing to construct a strategy that's based on our assumption that our competitors will always use the classical approach to their business from now on? I don't think so. But even ignoring our competition, what if our own card production process shifts tomorrow morning in the middle of graveyard? We need to know that instantly, because when we go to making playing cards, our process goes really fast. If something happens to it, we need to know instantly. That's one of the values of non-parametric approaches. They will enhance any method that we come up with for predicting our production process as long as it's based in some way on statistical inference. Now I want to close by broadening my discussion. If I was a reliability person and also a consumer for any metric that called itself a mean anything, like, I don't know, mean time between failure, I would seriously consider taking a look at the Bootstrap version of that same region to see if anything new suddenly pops up for the first time. QC labs happen to sit astride of a huge stream of data that comes through their doors. If they're in the hospital, it's coming through their doors 24/7, 365. If I was managing a QC laboratory that was feeding data back to doctors to be used for hospital floor decisions, I would definitely look for places where I could use a Bootstrap as a watchdog to increase the stability and the assurance of my measurement and validation structure. I'm really liking making these videos. If you want me to keep going, tell me.